Hello and welcome to this video on box plots. Now what box plots are for are to show how the data is spread out in different portions of the data. So it's a really good visual way to see how spread out is the data in the bottom quarter of the data, how spread out is it in the next quarter of the data, in the next quarter and the top quarter. And we'll see how to draw one of those with this example. So let's remind ourselves from the previous video how we find quartiles from the data. And if you haven't seen that video yet, can I recommend that you watch that first. So let's count the number of items we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And do you remember there was a trick that if the number of items was 1 less than a multiple of 4, we could add 1 to it to get 16, divide that by 4 to get 4, and then the lower quartile was that item, so the 4th item. The median was the 8th item, we just do multiples of 4, and the upper quartile is the 12th item, the next multiple of 4. So if we read those off, so the 4th item, 1, 2, 3, 4, it was a 9-year-old, and then the median is the 8th item, 1, 2, 3, 4, 5, 6, 7, 8, 13, and then the 12th item, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is 17. Now the way we draw it is this. Let's give ourselves a number line first. And we go like this. And what we do is we first draw vertical lines for the lower quartile, the median, the upper quartile. So the lower quartile is 9, so it's about here. So let's do a vertical line, leaving some space just below it. And then the median, 13, so it's about here. Making sure this is a line of the top and the bottom of that. And the upper quartile is 17, so let's put that there. And then what we do is we join these up to form a box. And then we need to plot the minimum and maximum values as well. So the minimum age is 5, and what you do is a smaller line and join it up like that. And then we've got the maximum age is 30, so we do a smaller vertical line like that and join it up so it's vertically symmetrical. And there is our completed box plot. And what this is supposed to show is that the box in the middle is to show like the middle 50% of the people. So here, that box in the middle is the middle 50% of ages. And then we can also analyse each quarter of the data. So that represents the bottom quarter of the people, that represents the next quarter of people, the spread of ages, that represents the next quarter, and that represents the next quarter. And because of this lovely visual way of displaying the data, we can compare how spread out the data is in those different quarters. Can you see in the top quarter, the ages are really spread out, because between the upper quartile and the maximum value, we can see there's a massive difference in age between 17 and the 30. Whereas we can see in the bottom quarter, the ages are relatively less spread out. So let's answer some questions based on this. True or false? There are more people with an age above 17 than below 9. And what this is trying to kind of suggest is that, well, this is above 17, and this line is longer than the length of the line below 9. But this is actually false, because these actually represent the same number of people. This represents 25% of the data, and this represents 25% of the data. So it represents the same number of people. It's just that the ages of the top 25% of people are more spread out than the bottom 25% of people. So that would be false. And let's say we want to complete this question. 75% of people have an age above what? Well, if 25% of people have an age above a particular value, that means we must be 25% along the data. So 25% along the data, we get to here, and we can see that's an age of 9. So the answer would be 9. We know that 75% of the data is above the lower quartile, which is here. And just to summarise what each of the parts of the box plot are, that there is the minimum value, that here is the lower quartile, that there is the median, that there is the upper quartile, and that there is the maximum value. Now, to test your understanding so far, we've got these values here, and I want you to draw a box plot for this data. You may want to pause the video now and have a go at that. Right, let's do it. We need to work out the quartiles and the median first. So how many values have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 1 less than multiple 4. Add 1 is 16. Divided by 4 is 4. So we want the 4th item. 1, 2, 3, 4. That's the lower quartile. Then the next 4, 1, 2, 3, 4. So the median is 15. And then 1, 2, 3, 4. the upper quartile is 25. And then we need an appropriate axis, so let's go from, say, 0 to 30. And then let's first put on these quartiles here. So we've got the lower quartile is 8, vertical line. The median is 15. The upper quartile is 25. Join that up to form a box. And then we've got these tails. So we've got a minimum value of 3, so we need to go down to 3 like that. And the maximum value is 28, so we're going to go up to 28. And how could we interpret this? We can see that the data is more spread out above the median than it is below the median. So the data is more spread out above the median, and that's because this box here on the right is wider than this box. We can see that between halfway through the data and 75% of the data, those values are more spread out than in the quarter of the people below that. Now, one thing you also have to do with box plots is to compare two different box plots. So we've actually got two on the same number line here. We've got the maths test scores of some boys and we've got the maths test scores of some girls. Now, usually this would be a 2-mark question or maybe even 3 marks, and we need to think of some properties to compare the girls' scores and the boys' scores. So one of the things we always compare is the median. So how could you compare the median of the boys' scores and the girls' scores? Well, you can see that the median, that's the median there for the girls, their test score median was greater than that of the boys. So let's write that. The median test score for the girls was higher. And it's not enough to just state what those medians were. You could say the median for the girls was, say, 74, whereas the median for the boys was, say, 65. That's not actually a comparison. Although it would be useful to actually state what those values were, you need to actually say which one was greater, or maybe if they're the same value. So you get 1 mark for that. And then you also have to compare some aspect of spread. And by spread, it could be the range, or it could be the interquartile range. So let's compare, say, the interquartile range. Which has a greater interquartile range? Well, the interquartile range is the width of that box. So that width, you can see, for the boys is greater than that width for the girls. So we say the interquartile range of marks for the boys was greater. And if the question had more marks, then I'd recommend you actually work out what those interquartile ranges were from the box plot by reading off the upper quartile, the lower quartile, and subtracting those.